Calculus Week 6 Solution. Introduction. This marks the end of the 6th week of 1 year with Calculus. Congratulations to everyone who participated this week. This video will be released after the week ends to guide you through the key ideas covered. At the end will be the scores of the week. This week's question asks us to find the absolute extrema for a function over a given interval. It wasn't specified if it's the maximum or minimum extreme value. By default, we would have to find both. We would have to differentiate to determine the turning point of the function. Let's learn. As you must have known, the extreme values, maximum and minimum, of a function on the interval can only occur at the critical point where the derivative of the function is 0 or at the endpoint of the interval. Testing the critical points. Take the derivative of the function. D dx f of x is equal to d dx 5 divided by x power 4 minus 30 divided by x power 6. It will help to write this in indices. Differentiate as normal. The derivative of ax power b is equal to a times b times x power b minus 1. Simplify. This is equal to minus 20 times x power minus 5 minus times minus 180 times x power minus 7. Remember that at the critical points, the derivative of the function is 0. This means that the derivative of f of x, the critical point, is equal to 0. Therefore, at the critical point, the derivative is equal to 0. This implies that 180x power of minus 7 is equal to 20x power minus 5. If we divide both sides by 20x power minus 7, we would be able to simplify the value of x power of x. Sometimes we cancel out, and you're left with 9 is equal to x substitute c power of 2. If we take the square root of both sides, we'll get that x substitute c is equal to plus minus 3. But we're only going to take the value of x substitute c is equal to plus 3 because the interval is from 0 to 10 and negative numbers are not included. So we evaluate the function at x equals to x substitute c. That means we're integrating the function, we're evaluating the function at x equals to 3. Multiply the left hand term by 9 over 9. Simplify now, then the same denominator, so we can add them, subtract them together. 45 minus 10 is 15 divided by 7 is 9. Simplify, get 5 divided by 2 for 3 is approximately 0.0206 for the decimal places. Testing the interval limit. Evaluate the function at the lower interval and we get f of x when x equals to 1 is minus 25. That means the second point of x comma y is equal to 1 comma minus 25. And at the upper limit, at the upper interval, we are evaluating f of x at x equal to 10. And we get 470 divided by 1 million, which is equal to 0.00047. Therefore, the third point of x comma y is 10, 0.00047. Now that we have the three possible extreme values, the Determine which is the maximum and the minimum. These are our first point. These are our second point. And these are our third point. If we arrange the values of y in ascending order, we would have that minus 25 is the lowest point and 0.0206 is the highest point. So the point that has minus 25, the value of y is minus 25, the minimum, and that have 0.0206 is the maximum point. Before I finally state the final answer, I would like to note that number 1, the extreme values are the y terms, the local of extremum are the x terms, and the extreme points include both the x and y terms. Now let's state our answer. The absolute maximum value is 5 divided by 243, and this occurs at x equals to 3, and the absolute minimum value is minus 25, and this occurs at x equals to 1. This is the picture solution. Some may find this as an easier alternative to the method used initially. Feel free to check it out. The first part of the solution will show now, and the second part of the solution will show now. Closing remarks. This solution is brought to you by IgweMatics. Support me by subscribing to my various platforms, leaving a like or a positive remark. Big thank you to Professor Chris McMullen for the question. That brings us to the end of week 6, 1U with calculus. Weekly reports. There were sadly no participants. Congratulations to everyone that participated, though nobody participated. Next week's question is coming soon. Can't wait to see your solution. Good luck. Thanks for watching.